Dinosaur we thought we knew had a secret twin lurking in the shadows.
Imagine a pack discovering that the giant tyrant shared its world with a nimble cousin we almost missed.
New evidence isn't science fiction. It's a fossil that rewrites what we believed about tyrant dinosaurs.
Watch it. Grab your field notebooks and curiosity, because today's journey through time will change your view of ancient predators.
These voices are synthesized by AI, but the curiosity is ours.
We share the thrill of discovery with you, even if our voices come from code. Our pack is human at heart.
This episode will trace the life of a forgotten predator, from dusty archives to debates that rage for decades.
We'll explore how scientists mistook a sleek hunter for a teenage tyrant and why that matters for all budding explorers.
We'll dive into data, weigh myths against evidence, debate respectfully, and spotlight your questions and passions along the way.
How a tiny tyrant upended the giant story, and why that twist inspires our curiosity.
Our journey begins in the 1940s, when a field team unearthed a medium-sized theropod skull in Montana. Dr. Dunkel and his crew marveled at the slender jaws and long teeth, thinking they'd found a relative of Gorgosaurus.
A few years later, Charles Gilmore examined the skull and classified it as a different species called Gorgosaurus lancensis.
For decades, the specimen sat in a museum, gathering dust and sparking whispers among those fascinated by tyrannosaur relatives. In the 1980s, paleontologists re-examined the skull and realized its features didn't match other small tyrannosaurs.
Colleagues boldly named a new genus Nanotyrannus, meaning dwarf tyrant, and the controversy began.
They described a sleek predator, half the length of its giant cousin, with long limbs and more teeth than expected. Not everyone agreed. Some experts argued these bones were simply juvenile tyrannosaurs that would bulk up and lose teeth as they grew.
This dispute simmered quietly until the early 2000s, when a remarkable skeleton, nicknamed Jane, was discovered in Montana.
Jane filled a size gap between known youngsters and adults. She seemed too lanky and toothy to fit either category neatly. The Burpee Museum even hosted a Tyrannosaur symposium to debate Jane's identity, inviting experts to argue over bones and growth.
Private collectors unearthed a breathtaking fossil pairing a horned herbivore and a small tyrannosaur locked in battle.
Dubbed the Dueling Dinosaurs, this fossil preserved a predator and prey entwined at the moment of death, an unprecedented snapshot. For years, the specimen remained hidden in private hands, fueling speculation and delaying the science that could answer our questions.
Finally, the North Carolina Museum of Natural Sciences acquired the Dueling Dinosaurs and began a careful public investigation.
Meanwhile, scientists continued to argue, were Nanotyrannus specimens actually juvenile tyrants or a real species with unique traits? Those favoring the juvenile hypothesis pointed to growth rings and the idea that young tyrannosaurs looked different before bulking up.
Insisted the differences were too dramatic. Nanotyrannus had more teeth, longer arms, and fewer tail vertebrae than any young tyrant. Look at those razor rows.
Imagine a youngster having to shed bones and tooth sockets to become an adult. Such an idea defies how vertebrates grow. As the debate raged, Jane stood in the middle like a lanky teenager, neither fully adult nor obviously a separate creature.
Researchers suggested that the supposed lanky phase of the giant tyrant was Nanotyrannus posing in disguise.
Other experts countered, saying that if Nanotyrannus were real, two tyrant predators coexisted side by side, partitioning prey like lions and cheetahs. The image of a single king ruling the Late Cretaceous is compelling, but ecosystems often support multiple hunters with different strengths.
Back in our lab, the discussion spilled into comments on past videos. Some of you compared this to misidentifying Tasmanian tiger.
Like those mysterious footprints, Nanotyrannus evidence required patience and multiple perspectives before we could say what left those marks. Our pack's questions about extinct species sometimes lead to passionate discussions. This debate has been similar, bridging science and curiosity.
As we set the stage, remember that behind every bone is a story of discovery, misinterpretation, and eventual clarity.
We're telling this story not to dwell on past mistakes, but to celebrate how science corrects itself when new evidence surfaces. In our next chapter, Axiom will open the vault and walk us through the evidence that ended this debate.
Stick around, because the myths we are about to bust will change how you see tyrannosaurs and the fossil record.
Let's audit the juvenile hypothesis first. Researchers argued that a young tyrant would have slender bones and more teeth before maturing. They noted that growth rings in some leg bones matched the growth curve expected for the giant king during adolescence.
View,
Nanotyrannus fossils simply captured a teenager halfway to becoming an apex predator, not a separate species.
Thomas Carr's influential analysis suggested that as the giant tyrant aged, its skull broadened and tooth count decreased dramatically. Under this scenario, Jane and the Cleveland skull were just transitional growth stages that filled a predicted ontogenetic gap.
Critics of Nanotyrannus argue that the simplest explanation is one species changing shape rather than two similar predators sharing territory.
They leaned on parsimony, saying evolution seldom allows nearly identical carnivores to compete for the same prey without divergence. Histology supported them for a while. Leg bones sectioned from small tyrants showed growth patterns consistent with ongoing growth.
Let's examine the counter-arguments. Proponents of a distinct species highlighted features that don't change as animals grow.
These include extra teeth per jaw, elongated arm bones, and fewer tail vertebrae, traits that cannot simply vanish with age. If it were a juvenile, it would need to lose tooth sockets and vertebrae while growing, which vertebrates don't do.
Opponents like James Napoli noted that the combination of long legs and more teeth placed Nanotyrannus outside known growth sequences.
They argued that expecting a teenager to reabsorb vertebrae and shrink arms defies everything we understand about vertebrate development. The debate persisted for decades because neither side had a full skeleton that conclusively showed maturity and unique traits.
Enter the Dueling Dinosaurs Tyrannosaur, a nearly complete specimen preserved alongside a Triceratops, offering unprecedented data.
When scientists at the museum analyzed this animal, they left no stone unturned. High-resolution scans, histology, and biomechanics. One finding: the leg bones had stopped growing. Rings showed the animal was roughly 2 decades old.
Fused vertebrae and mature skull sutures confirmed this individual was fully grown, not an adolescent awaiting a...
In contrast, a giant tyrant of that size would have been much younger if it were destined to reach enormous lengths. The specimen's long arms and proportionally long legs didn't match any growth stage of the giant king, signaling a different lifestyle.
The tail held fewer vertebrae than in the giant predator, a structural difference that cannot be explained by youth alone.
Inside the skull, researchers found an extra sinus and differently shaped canals for cranial nerves, further distinguishing this animal.
Even the number of teeth per jaw side was higher than in any known giant tyrant, aligning with earlier Nanotyrannus specimens.
A new phylogenetic analysis placed this animal outside the main Tyrannosaur family tree, suggesting a parallel branch of tyrant relatives.
This analysis even identified 2 species within the genus, the classic form and another slightly different one represented by Jane. The second species was named after Lethe, the mythological river of forgetfulness, acknowledging how overlooked these fossils had been.
The tail held fewer vertebrae than in the giant predator, a structural difference that cannot be explained by youth alone.
The suite of mature traits makes it biologically impossible for a Nanotyrannus skeleton to grow into a giant tyrant. Lawrence Whitmer, an independent paleontologist, praised the study's rigor and called the results as definitive as paleontology allows.
What does this mean for our understanding of the giant tyrant's life history and the Late Cretaceous ecosystem?
For starters, it adds another predator to the scene. The giant tyrant was not hunting alone in those ancient landscapes. Like lions and cheetahs today, the heavy hitter and the sprinter likely partitioned prey and habitats to avoid constant conflict.
Nanotyrannus, with its long legs and lighter frame, was probably faster and targeted smaller or swifter herbivores than its cousin. Those proportions hinted a predator.
Meanwhile, the giant tyrant focused on bone-crushing bites and massive prey, filling the apex role with sheer power. This reinterpretation forces scientists to revisit models of growth. Perhaps the giant tyrant didn't go through such a lanky teenage phase.
Many studies built on misidentified specimens must now be reconsidered. Our view of ontogenetic niche shifts may be oversimplified.
As scientists re-examine data, they'll separate Nanotyrannus from the giant tyrant and redraw growth curves, feeding behavior, and predator interactions. Histories written in bone are not static. New tools like high-resolution imaging, biomechanics, and phylogenetics reveal hidden details.
Our community, this is a powerful reminder that science thrives on questions. Your curiosity fuels these discoveries.
As always, I encourage you to post your own observations, link your sources, and respectfully challenge claims in the comments.
We'll shift from data to dialogue. Lumen and I will examine the picture and invite you into the conversation.
Stick with us as we unpack the societal implications, explore myths, and connect your own questions to this prehistoric drama.
Remember to pause if needed and reference the sources panel. We want you to verify our claims and build trust.
Tyrannosaurus rex, and today we're looking close to dinosaurs with fossils. And here's the tracks.
All set? Let's head into the debate and see how different perspectives illuminate the story of this tiny but mighty hunter.
So, Axiom, hearing all this data, I feel like we've been living with a giant misunderstanding for decades.
It is a good reality check. Our field often mistakes young animals for new species. Skepticism keeps us careful.
True, but I love how this twist adds depth. Two predators sharing a world make it feel like a wildlife drama.
It does, and it forces us to rethink growth models. Perhaps the giant king wasn't fast during its youth.
I also think about our viewer who asked whether dolphins could develop technology. Constraints shape evolution, just like hands shape tools.
Great point. In this case, limb proportions shaped hunting strategy. Long arms and legs make Nanotyrannus more agile than its cousin.
It reminds me of lions versus cheetahs. One uses raw power, the other uses speed. Both thrive by specializing.
Exactly. Ecological partitioning prevents direct competition. It's a principle that applies from dinosaurs to modern carnivores.
Our community often debates whether bringing back extinct species is wise. Here, nature shows how multiple predators can coexist.
Though we shouldn't conflate de-extinction with paleontology, the principle of ecological balance still matters in those conversations.
Speaking of conversation, I want to shout out the viewer who compared mice-identified fossils to double-registered footprints. You were onto something.
Yes, misinterpretation happens in many fields. That's why transparency and peer review are crucial. Thanks for keeping us honest.
I feel a woo howl coming on. Learning Nanotyrannus is real feels like finding a hidden level in a game.
Hold that excitement, but remember to question. Does this narrative pass the smell test? Tell us what evidence you want.
I wonder how many other fossils we mislabel. Maybe tiny but mighty predators hide among bones we've called juveniles.
That's a research frontier. Scientists will likely re-examine other specimens once thought to be young Tarbosaurus or Albertosaurus.
If you're just tuning in, don't worry. We always recap and keep our pack up to speed. Drop questions in chat, fact.
And please cite your sources. We love when viewers back up claims with links or personal observations from the field.
Do you think Nanotyrannus hunted in packs or sprinted solo? Imagine a fast group nipping at herbivore heels.
Interesting question. The fossil record rarely shows group behavior, but the dueling dinosaur scene hints at an opportunistic attack.
Our previous video about microshorts taught us that tiny bursts can captivate. Maybe these animals use quick bursts to outmaneuver prey.
Let's not stretch analogies too far, but your point stands. Speed matters. Long limbs indicate a predator built for pursuit.
Another viewer asked whether the giant tyrant could have preyed on Nanotyrannus. They picture a lion grabbing a hyena's meal.
Predator-on-predator violence is possible. We know Nanotyrannus attacked a full-grown horned herbivore, so bravery wasn't lacking.
I'm imagining the tiny tyrant as a sprinter that nips and dodges, while the giant tyrant charges like a freight train.
Nice metaphor. Remember to ground those images with data. Long legs and reduced mass translate into higher speed estimates.
Before we head into case studies, take a moment to tap like and share your favorite fact so far.
And if you want to go deeper, pause now and open the sources panel, then come back for real-world examples.
Jane stretched from snout to tail and was remarkably complete, filling a gap between known juveniles and adults.
When I first saw pictures of Jane, her slender skull and long legs reminded me of a sprinter built for speed.
Many experts viewed Jane as a teenager of the giant tyrant, but her long arms didn't fit that story. Jane's jaw held more teeth than any young giant tyrant known. That detail, Blanterienzo, a tale planted doubt in my mind. She was displayed for years as a juvenile giant tyrant in the Burpee Museum, teaching visitors a story that would change.
Fast forward to the dueling dinosaurs. Seeing a smaller tyrant and a horned herbivore locked together gave me chills.
I imagined what happened. A predator biting at a frilled giant, both toppled by mud and fate. That tableau is rare. Having predator and prey preserved in combat offers insights into behavior we can't get from bones alone. It shows Nanotyrannus wasn't just scavenging. The smaller tyrant actively attacked a powerful horned herbivore and paid the ultimate price.
The museum made the investigation public, live streaming prep work and inviting citizens to watch and ask questions in real time.
That transparency resonated with our channel's ethos. We strive to show you the messy process behind polished conclusions. Watching the Dueling Dinosaurs prep felt like binging a slow burn series. Each brushstroke revealed something that shifted the narrative. When the analysis came out, confirming maturity and unique anatomy, I literally jumped out of my chair and called axiom.
True story. She called me during dinner and shouted that the Tiny Tyrant was real. We laughed at the irony.
The museum also released an infographic comparing Nanotyrannus and the giant tyrant, highlighting differences in length, weight, arms, and teeth. Seeing those contrasts side by side made the case intuitive. Even a child could tell they weren't the same animal. I count important takeaways on my fingers. First, discovery. Second, debate. Third, decisive evidence. That's our narrative rhythm here.
For our pack, the lesson is clear. Question labels, dig deeper, and celebrate when curiosity overturns old assumptions.
This case also connects to our de-extinction discussions. Resurrecting species requires getting their identity right before we bring them back. Absolutely. Misidentifying fossils could lead to misguided restoration efforts. Accuracy is ethical responsibility in both paleontology and de-extinction. Our viewer who asked about using germ cell editing for dodo revival reminded us to consider ecological context before we intervene.
Similarly, discovering Nanotyrannus prompts us to reevaluate how we interpret juvenile fossils of other tyrannosaur relatives around the world.
Imagine if small fossils from Asia, called juvenile Tarbosaurus, turned out to be their own sleek hunters. The diversity would explode. That is plausible. The paper suggests predator diversity in the last million years of the Cretaceous was higher than we thought. Museums are already updating labels. Jane is no longer a lanky giant in training, but a proud member of the Nanotyrannus family.
The Cleveland skull, once a curiosity, now glows with renewed importance. Visitors stop longer and ask new questions.
Exhibits emphasize that science is a living process. Our understanding evolves, just like the animals we study evolved. Visitors find hope in seeing cherished notions overturned. They realize that being wrong is part of getting closer to the truth. This community loves seeing process. We invite you to share your favorite museum or field trip moment in the comments.
Maybe you saw a dinosaur bone for the first time and felt the same awe I did when learning about Jane.
Our pack thrives on these shared moments. Every comment helps us build a map of curiosity across the world. If you can't visit, check their virtual exhibit. You can explore Jane and the Dueling Dinosaurs from home. Online tours might not replicate the smell of plaster and dust, but they still connect you with this incredible discovery.
We'll place a link in the sources panel. Remember to pause and explore after the video finishes to deepen your understanding.
Beyond fossils, there are modern parallels. In Africa, lions share savannas with cheetahs and hyenas, each carving a niche. Research shows that apex predators coexist when they partition prey by size or time. The same may have happened here. Knowing this, Nanotyrannus becomes more than a name. It represents a dynamic ecosystem where different strategies coexisted in balance.
Every time I learn that dinosaurs were as varied as mammals, my imagination sparks and I feel closer to their world.
I hope this story inspires you to see fossils not as dry bones, but as characters in a drama being written. Take a breath, because up next we're shining a light on you. Our community spotlight is where your voices get heard. Welcome to the Community Spotlight. This is where we celebrate your brilliant questions, puns, and field notes.
One of you recently shared photos of mysterious footprints in your backyard and asked if they belonged to an extinct predator.
We explained that extra toes can be double-registered steps, or dew claws. You appreciated the nuance and promised to send time codes.
Another viewer worried that resurrecting extinct birds could behave like invasive species. We talked about reactivating ancient genes responsibly.
Your curiosity about gene editing shows how connected these topics are. Understanding dinosaurs helps us frame ethical decisions today.
We received a heartfelt note praising our de-extinction episode. You asked which part resonated most, and we loved your take.
Many of you jump into polls. Our predator poll showed love for coyotes, so we'll compare them next.
Shout out to the viewer who humorously requested a translator for rare animals like the fossa. We love your playful curiosity.
We asked which animal to decode next, and many of you chose the fossa. Your votes guide our future topics.
Some of you criticized budgets for de-extinction. We clarified funding sources and asked how you would prioritize research, breeding, or conservation.
Others replied with brief praise. We thanked them and asked whether they preferred wildlife spillover stories or human health angles.
One viewer offered photos of marsupial prints for us to verify evidence of a Tasmanian predator.
That willingness to contribute data warms our hearts. Citizen science isn't just a buzzword, it's a way we build knowledge together.
We're also grateful for constructive pushback. When you questioned our narration style, we reflected on authenticity and considered more human voices.
That feedback led us to emphasize our two-person team and to explain how synthetic voices assist without replacing human creativity.
It reminded us to show sources early. Trust grows when you can follow the trail from claim to citation.
Our comment section is alive with pun submissions. Keep them coming, and we might share a pun of the week.
Viewer shoutouts build loyalty. So here's to the pack members who consistently link sources and gently correct misconceptions.
We see you and appreciate you. Your curiosity and kindness make this channel feel like a real pack exploring together.
If you're new here, join the conversation, ask questions, share links, or howl with excitement when a tiny predator surprises us.
Don't forget to vote in our polls. Your choices determine which animals or ideas we explore in upcoming deep dives.
We also love hearing personal stories. Tell us about the moment a fossil, field trip, or science lesson sparked your passion.
Thank you for making this space vibrant. Next, we'll look forward and imagine what discoveries might follow this tiny tyrant.
In the future outlook, let's step back and think about how this discovery shapes upcoming research and technology. First, we can expect more multidisciplinary studies that combine imaging, histology, biomechanics, and computational modeling to test species identities. The success of the Dueling Dinosaurs investigation shows that open access to data and public engagement accelerates scientific progress. We may see more citizen scientists invited into labs, scanning fossils, and helping to annotate digital models from home. On the academic side, paleontologists will revisit collections, looking for other mislabeled juveniles that may represent new species. Bone histology is becoming more precise. New techniques can estimate age and growth rates without destroying valuable specimens. Advances in biomechanics software will allow researchers to simulate locomotion and biting mechanics, comparing speed and force across extinct predators. We also expect more refined evolutionary trees as new fossils fill gaps. Placing Nanotyrannus outside the Tyrannosaur family challenges assumptions. Could there be a branch of slender, fast tyrants we haven't recognized? This question will drive expeditions to underexplored formations. Technology might even let us reconstruct soft tissues. Imagine knowing the muscle mass differences between the tiny tyrant and its cousin. On the outreach side, this discovery will likely inspire new documentaries and educational games featuring Nanotyrannus as a character. I'm hopeful that kids who love the giant tyrant will also root for its nimble neighbor, learning about ecological niches. As this narrative spreads, we must guard against sensationalism. Accurate representation builds respect for both the science and the animals. Our channel will continue to highlight ethics. Should we use our tools to resurrect extinct predators or focus on preserving living ones? In any scenario, the story of Nanotyrannus reminds us to keep asking questions and to stay open when new facts emerge. As we wrap up, remember the key beats: a forgotten skull unearthed, a long debate, and decisive evidence for a tiny tyrant. We learned that science is iterative. Mislabeled juveniles can become new species when we apply better tools and open minds. We discovered that ecosystems are richer than a single king. Predator guilds share territory by specializing in speed or strength. And we celebrated how our community fuels these stories with questions, field notes, and constructive feedback. You make this journey meaningful. If this resonated with you, like, subscribe, and howl in the comments. Share your questions and ideas, and we'll explore them together.